Hello math enthusiasts, welcome to section 3 part C of double integrals. In this section we're gonna to calculate this value, exactly the solid bounds between cylinder of x squared plus y squared equal 4 and these two hyperplane z equal 4 minus y and exactly this plane z equal to 0. What we must do? We must learn double integrals. Let's dive in it. At the first, we know our region is a circle. Exactly this circle between minus 2 and 2. This formula is y equal 4 minus x squared. But another one, exactly the same, but with a minus. Yes, that is the function form of this equation. But we must now write the boundaries for double integrals. Of course, the interior integration with respect to y, but another one with respect to x. As you know, your x is between minus 2 and 2, and your y is also between minus radical 4 minus x squared and the positive side. But what is your integrand? Z equal 4 minus y. Right now we must calculate this integration. At the first, this partial integration with respect to y. Answer is 4y minus y power 2 over 2. Right now I put the limit boundaries 4 minus x squared and the positive. Right now I substitute this variable in here is exactly 4 radical 4 minus x squared minus, when I put this radical exactly here, radical vanished and 4 minus x squared over 2 minus lower bound is 4 minus x squared minus 4 minus x squared divided 2. But let's go to simplification. Minus and minus, that is positive, therefore this part and this part cancel. Minus and minus also is positive for radical 4 minus x over 2. 4 and 4 is 8 radical 4 minus x squared. But right now we must calculate this integration between minus 2 and 2 with respect to x. Do you think we must calculate that? No, not at all. Why? Also we can use the trigonometric substitution, but be a little genius, guys. That is exactly this part of circle, yes, the positive side. We know that is r equal 2. But if we're gonna to calculate this area is pi over 2, but because it's not whole of the circle, but it the last divided 2, therefore is 4 pi over 2, that exactly 2 pi. But right now I substitute in here 2 pi and our total answer is 16 pi. Thank you for watching this video. Don't forget to subscribe me. I'll see you in the next video. Take care. Bye bye.